Welcome everyone to the HL7 open source tooling series. Today we welcome the infamous and very valuable FHIR community member, James Agnew, to share information about the HAPI FHIR project. So I'll turn it over to him now.
Awesome. Thank you very much, Sandy, and welcome everyone to this webinar. Let's kick this off and talk a little bit about HAPI and the HAPI project. A little bit about me before we get started. I have the most professional bio I could possibly, professional headshot I could possibly find. I have been the CTO, and I call myself the head geek with Smile Digital Health for 2017. Smile is a company that supports HAPI. I'll talk a tiny bit about that a little bit later. More importantly, to today's webinar, I have been the project lead for the HAPI project since all the way back in 2004. Always makes me feel old saying that, but there we go. And I think most importantly, I have been a huge advocate for open source and standards for, well, a long time now. So I call myself a standards geek for life. I'm a firm believer in the mission of HL7 and the work that we're all doing together. So there we go. This incidentally on my picture is my sidekick, Dharma. She's sitting almost right next to me in the office today. So there we go. Really hoping she doesn't bark during this webinar, but we'll see what happens. What I'm going to do today, instead of doing deep dives, is I'm going to talk about some of the highlights and just give you a sense of what is HAPI FHIR and what can it do for you using the many components that we've got here. So let's start up at the top. So HAPI FHIR provides a set of Java classes that model every single one of the FHIR resources in every major version of the FHIR spec. If you were astute and have been following FHIR for a long time, you'll notice there is a missing version of my list there. That's the DSTU1 version, the original release. We did drop support for DSTU1 about 4 years ago based on a bunch of community feedback that nobody was really using it significantly. It's funny, over the years we always end up discovering that there are pockets of people that still do use the DSTU1 version, and we know that they exist, but for the most part, people have moved on from DSTU1, so we've dropped support for that. We have no similar plans to drop support for DSTU2 because it is still in pretty wide production use, so I think this is probably going to be the list for the foreseeable future. Point being, we support every resource type that's in every one of these versions of the spec. We do also tend to support upcoming draft versions. For the longest time while R5 was under development, we supported the current drafts of R5. We'll be adding draft versions of R6, I suspect, before long as well. These model classes have lots of interesting properties. You can extend them to add extensions to them if you want. You can extend them to add constraints to them if you want. You can even create your own custom resource classes if you want to create custom resource types. And all of that is fully supported by the library. And then these model classes can be plugged into our Parser Serializer framework. And the Parser Serializer is a really powerful thing. It does the obvious things of parsing and serializing the wire formats of FHIR, and that includes all three major wire formats: the JSON format, the XML format, and the Turtle RDF format. In the real world, I mean, people almost always use a JSON these days, so it's not really that important to support the other two. But there are people with really good, interesting use cases for Turtle that are working in that space, and certainly there is some use of FHIR's XML format. I find that format is slowly going away. I don't know, nothing more than personal opinion, but I find less and less you see people using the XML format in the wild. But it is still a first order format supported by FHIR, and I don't think it's ever going to truly go away. I mean, it will remain supported forever, I'm sure. And there we go. So those are that's the parser and the serializer. This is the only code snippet I'm going to show you today, because the point today is not to do deep dives into code, but this is a simple example of using our data models. You can create classes, you can populate them with data, you can use our parser to serialize them, and this is a really simple code snippet example that hopefully is fairly self-explanatory in terms of how you would use our library to create a FHIR object and then serialize it into its wire format. That's how you do that, and this is all powered by this thing called our FHIR context, which is a thing you will learn about if you get more in detail into the FHIR training. The next thing I'm going to talk about is the FHIR client. This is a big part of our library as well. Certainly, if you're building applications that need to talk to FHIR servers, having a client is a useful thing. We've got a very full-featured client. There's actually two FHIR client frameworks within HAPI FHIR. I'm not going to talk about the distinction because it's really well documented on our website. And that distinction isn't super important. But we do have these two client flavors. And then we've also got a special Android client flavor, which sort of extends the regular client for use on Android devices. If you're not aware, Android developers use a Java derivative language. They can write their code in either Java or another language called Kotlin, but both of these languages sort of can interoperate with standard Java libraries, and HAPI FHIR is such a library, so you can use us on Android as well. And notably, we are a key component of Google's Open Health Stack framework. And I'm not going to say too much about Open Health Stack here either, but it is a really neat framework doing some very cool work. So if you're interested in sort of what's the state of the art of people building open health applications for Android, do go check out Open Health Stack. Very cool team over there as well. They do some really neat stuff. So there we have it. This is the most important thing I'm going to talk about today, and that is the server framework that we provide, the plain server and the JPA server. I sometimes refer to these as the workhorses of the HAPI FHIR framework. And the reason I say that is you can use HAPI FHIR to do all kinds of things, and lots of people do. But the biggest use case that we see people using HAPI FHIR for kind of mirrors the biggest use case that we see the Java language in general being used for, and that is for building servers. Java is just a really good server language. That's kind of its biggest strength. And HAPI has sort of followed in that same vein. So we provide two parallel server frameworks. These server frameworks do build on each other. They have a lot to do with each other, but they've got very different use cases. So let's talk about that for a second. HAPI FHIR provides what we call the plain server, and that's often referred to as a facade, which is a mechanism that we use to allow you to layer FHIR capabilities on top of existing applications that don't today use FHIR. The plain server doesn't have any requirements around how you do storage, what your database schema looks like, what your existing interoperability looks like. None of that matters. You can layer FHIR onto really any Java-based application. I guess it doesn't even have to be a Java-based application as long as you're willing to add some Java to it. The plain server allows you to do that. If you think back to my previous use case, we, way back 10 years ago at University Health Network, we had a proprietary data repository that had nothing to do with FHIR. And in fact, FHIR didn't even exist when we created it. And our very first use case for HAPI FHIR was creating this plain server. That was the entire reason that we created HAPI FHIR. And 10 years ago, we assumed that was the only use case for HAPI FHIR. Of course, lots of other things came along, but that was the thing that we wrote. Or that we intended. Most importantly to the plain server, you are the one writing the storage logic. So, you might be writing code that talks to a database and maps the tables and columns into FHIR resources. You might be reading data out of flat files. You might be talking to a NoSQL database like CouchDB or Cassandra or something like that. And we've seen examples of both of those, by the way. So you're providing the storage logic. That's most important. The most important thing about plain server. So you can use this in all kinds of interesting places. The JPA server, aka the HAPI FHIR repository model, is a very different kind of beast. We often call it a complete server in a box. And what that means is, unlike the plain server where you're writing the storage logic, with the JPA server, we provide our own storage logic. So we provide a database schema that you have to use. It is optimized for FHIR data in general and the way that FHIR data gets indexed. It requires a relational database underneath it. Most often people pair it with Postgres, which is of course the most popular open source database these days. But we do also support a number of other databases, Oracle and Microsoft SQL Server being the two most common ones. So, effectively, we provide the storage logic there, and you can deploy the JPA server and just instantly have a working, running FHIR server running wherever it is you've installed it. The plain server, has a bunch of interesting use cases worth talking about. So, as I said before, this was the original reason for creating the library. Things that we've seen certainly include, vendors who produce things like EHRs, EMRs, data warehouses. I mean, you pick your three-letter acronym for a system that exists in a healthcare setting. If you want to add FHIR capabilities to it, the plain server could be a way to do that. We've seen people using this platform for adding FHIR capabilities on top of non-FHIR services. People will wrap SOAP services, REST services that don't speak FHIR. Often they'll wrap those things with HAPI FHIR in order to provide a FHIR view on top of them. We've seen people creating things like static registries where there's reading a list of perhaps practitioners out of a flat file and then serving that up as a static read-only FHIR server. We've seen people use HAPI FHIR to develop all kinds of POC applications, and often those get brought to production. I will certainly stress this entire framework gets used very heavily in production. That's a question we often get is, can I bring this to production? Is this ready? And everything I'm showing you today has been well tested in production and has had lots and lots of production use. So do feel confident you can do that. The JPA server is, as I said before, it's a full-featured server in a box. Comes with a whole lot of interesting benefits. I mean, portability is one of the critical ones. As I said before, it runs on Postgres. It'll run on SQL Server and Oracle. We use a framework called Hibernate, which is an object relational mapper, an ORM platform that supports a number of other databases. And I am aware of people who have run HAPI FHIR on things like CockroachDB, Cache from InterSystems, the FHIR, what's it called? Firebird database, IBM's DB2. I've seen people run HAPI FHIR in all kinds of places. I will say the three that I've listed up here are the three that we test frequently. So those are the ones we recommend using, but we've seen it work in other places. Equally important, you can run HAPI FHIR almost anywhere. We've seen it run, certainly on local workstations and laptops, all of the major clouds, AWS, Azure, GCP, OCI, IBM's Bluemix even. We've seen people run HAPI on all of those places, and it runs very happily there. We've seen people run it in private data centers, on Windows, on Linux, all supported. We're aware of people running the JPA server on Raspberry Pi boxes. I've tested that a few times myself just for fun, and it works quite well. So there we go. You can run HAPI in all kinds of neat places. It's really hard to talk about the features of the HAPI FHIR JPA server just because there are so many of them. I mean, we've been building this thing now for almost 10 years, and it is just a monster of a project. We aim really to be a complete and very accurate representation of the FHIR spec. So we've tried to implement most of the corner cases in there. FHIR keeps growing and we keep trying to catch up. So we'll never really be truly done with that. But we do provide a lot of features, and I don't nearly have time to talk about all of them, but I do want to sort of talk about a few of them. Interestingly here, we do support subscriptions, which of course is the mechanism for PubSub, getting notifications about changes to data. We've got extensive support for custom search parameters. So, if you're creating your own custom extensions, for example, and you want to spin up a search parameter on your FHIR server that supports those extensions, or you want to create some custom logic there, if you want to reindex your data after you've added new search parameters, if you want to create custom resources and then add search parameters to them, if you want to create what we call combo search parameters, which are search parameters indexing a combination of two other search parameters, if you want to create search parameters that enforce uniqueness across some value or some series of values, there's all kind. I mean, the sky is the limit there. There's a lot of interesting functionality around that. The JPA server includes a pretty complete terminology server as a part of it. You can upload your own terminology, you can create value sets, you can expand those value sets, you can use them as a part of validation, you can search them. So there's all kinds of interesting terminology services. We don't provide authoring tools. There's a lot of stuff our terminology services don't do. I certainly have to give a shout out here to the Onto server product from CSIRO. They are a much more complete terminology server than the one that we ship with. I guess the explanation I often like to give is that the terminology server that we've got within the JPA server is really geared towards validation use cases primarily. The Onto server product, which incidentally is built on top of HAPI as well, is a much more complete product. It supports the validation use cases as well, but goes well beyond that. They get into all kinds of interesting things like code picking for supporting UIs. They've got authoring tools. They've got really fascinating support for Nomad's expression constraint language. So a lot of neat stuff there. But with all of that said, there is a very powerful terminology server built into JPA server today. So that is, that's a thing you can use. We've got full support for the bulk import and export, i.e. the bulk data access implementation guide. Support for what we call partitioning, which is the ability for you to do things like multi-tenancy in your repository. And this is just a tiny subset of the features that exist within the library. There is quite a bit in there. Moving on from the servers, I'm going to move over to the side here and talk a little bit about security for a moment. Security is a really detailed topic, something that we dive into much deeper when we do the 3-day session. And I'm really only going to scratch the surface here, but I will tell you that if you're building FHIR infrastructure, including if you're using HAPI FHIR to do that, you obviously have to be thinking about security. I mean, we're dealing with health data, and health data is very sensitive, as we all know. It is critical when you're building health data architectures that you think about security. HAPI provides a number of building blocks that can be useful to you as you are standing up your data architectures for data interoperability. The three big pieces of the, I don't know, the three legs of the stool, shall I say, are the authorization interceptor. And the authorization interceptor allows you to declaratively write rules about what the user is allowed to do. This is important. The easiest way to explain what that means is to say that, let's say you're standing up an API that will allow patients to access their own data. And this, of course, with the CMS mandates as an example in the US, and there are analogs around the world for that. One of the things that people have been mandated to do is stand up consumer-facing APIs for health data. And of course, one of the important things about these consumer APIs, if you think about how they work, they've got access to data about every single patient that is known to the system. But it's vitally important that if James is accessing those APIs, James should be allowed to see James's data. Maybe James should be allowed to see like James's family's data or other people who have delegated James access to that data. So maybe there's a small list of patients that James can see. But anyone else, James should be absolutely prohibited from seeing. Like, that's absolutely critical. And if you start thinking about how FHIR servers work, I mean, there are all kinds of ways of bringing data in. You can do a direct search for the patient resource for James's identifier, and that might bring it. You might do searches for observations where James is the subject. You might do chained searches where you're looking for all the patients with a specific identifier or a specific gender and birth date combination. You might use reverse includes to bring in data that's been linked to from other resources. The FHIR spec in general, I mean, the point I'm making here is the FHIR spec has lots and lots of ways of using its APIs to bring down the same sets of data. And the authorization interceptor allows you to very quickly say, I want this user who is currently accessing the APIs to only be allowed to see data that is a part of this patient compartment or these patient compartments. In other words, only data that belongs to this patient or this list of patients. And with a couple of lines of code, the authorization interceptor handles all of the different nuances of the ways that people might get access to data. So it's a very powerful framework, allows you to write these authorization rules that sort of declare what should be allowed. I've only really talked about data access here, but it does apply to write use cases as well. You can state that this user should be allowed to write this type of data, but not this other type of data, or only data belonging to this patient of these resource types. Very flexible thing anyhow. And pretty well documented. So if you want to learn more about that, that's a thing you might learn about. The consent interceptor, the next one to talk about, allows you to apply consent rules. And consent is a super broad topic, another thing I don't have time to nearly get into all of the nuances of. So I'll quickly summarize it as saying that it allows you to apply filtering, masking, and blocking logic to any data read requests. And what's really critical here is you can use it to do basic data masking. If you want to pull specific elements out of resources before they get served up, that's possible. But much more importantly, if you've got rules where you want to both prohibit the user from seeing data, but also prohibit the user from even knowing that that data exists, you can do that. A really simple example that we've often seen used is, a US example, there's often rules where data of specific sort of sensitive types should not be allowed to cross state lines. In other words, if you're accessing an API from across state lines, there's certain very sensitive things. I'll use an example of like STI tests, sexual transmitted infection tests. Many places have rules where those are considered sensitive enough that they should not be allowed to be accessed in cross-state APIs. And very importantly, you don't want to create an API where if somebody queries for that, if it exists, they get an error back because they're not allowed to see it, because of course that is disclosing that the test exists in the first place, which is itself PHI. So the consent interceptor allows you to filter that data from results in a way where the calling user doesn't even know that data is being filtered from them. So you're not sort of disclosing the existence of sensitive data. There's a whole lot more nuance to that I won't get into here, but that's kind of a critical function of the consent interceptor. And then, of course, finally, when you're building your security or infrastructure, preventing access to bad data is one thing, but auditing who has looked at what is just as important. We provide an audit interceptor that provides an audit trail that is compliant with an IHE implementation guide called the Basic Audit Logging Pattern (IG). I've often shortened that to BALP. I don't actually know if IHE likes that acronym or not, but I like it because it sounds fun and it's kind of fun to say. So we call it the BALP Audit Interceptor, and that is a big part of HAPI for the last year or so. So those are the basic security primitives. I will say that we have a framework called the Interceptor Framework. Yet another thing I don't have time to do too much justice to here, but I will say we provide point cuts, they're called, and they are little sort of extension points just all across the library. And this is really a critical part to the HAPI FHIR design. You can layer on your own functionality almost anywhere within the framework. The diagram that I've got here, I'm not expecting it to make a whole lot of sense to you if you haven't worked with it before. But the thing I'm trying to show is that this is an example of a flowchart that shows how we serve server requests within the framework, and you can layer functionality all across the processing pipeline. So it's quite a neat thing. And in fact, we provide a number of built-in interceptors, including the security primitives I just talked about. You can create your own interceptors as well, so that's kind of critical. Talking a little bit about validation, you absolutely, these days, almost nobody does FHIR without thinking about validation, at least thinking about it, if not implementing a bunch of validation. Validation is a really extensive subject. It's kind of a difficult one to talk about because there are so many sort of decisions you need to make that we just can't make for you. I mean, decisions about when you should run your validation, what you should do with failures, should you reject failures, should you accept them but tag them with warnings, how strict should you be, should you forbid any data from being stored if it's got any validation failures, or should you allow it if it's got warnings but fail it if it's got errors? I mean, there's a lot of decisions there, and there's trade-offs with those decisions. We don't provide any opinion on those decisions within HAPI. The thing that we do is we provide a bunch of validation primitives that you can configure to meet whatever is appropriate for your specific needs. Those primitives include the following things. We provide the parser error handler, which is effectively a little inline validator that runs as we're doing parsing and can spit out some basic syntax errors. It's great because it's incredibly performant. I mean, it doesn't actually add any overhead at all to your performance, so that's kind of a nice thing. The workhorse of validation is the second bullet here, the instance validator. This is complete what we call profile validation. This uses structure definitions, value sets, code systems, all the big conformance resources that are a part of the FHIR spec. And these are all a part of implementation guides these days. It uses those to validate instances of resources or even collections of instances of resources, and will spit out a set of messages back. They might be error warnings, errors or warnings, or just informational messages about what they found. The instance validator, highly configurable. It can do lots of things, but effectively, if you want to do validation, that's probably where you're going to start. We provide interceptors that you can use on your servers to provide request validation or response validation if you need it. And we provide a complete package registry as well. These days, if you've spent any time dealing with implementation guides, a thing that you might or might not have noticed is that we use a format called NPM, the Node Package Manager format, to bundle up all of the technical artifacts that are part of an implementation guide. So that includes the structure definitions, the search parameters, the code systems, the value sets. Those all get packaged up into it's effectively a little zip file that is sort of formatted using the NPM format. You can import these files directly into HAPI FHIR these days. We provide a bunch of infrastructure to do that. You can store them within your repository if that's the thing you want to do. We even provide functionality that allows you to spin up your own local NPM server using our repository as the backing for that. So a whole bunch of interesting infrastructure around NPM packages that are in there. So do get in touch if that's the thing you're interested in doing. I'm going to close here with a quick demo of two things. I'm hoping I'm sharing what I think I'm sharing here. First off, I'm going to demo our documentation. There's not much to say here. I'm going to our website. All I want to do here is point out that we've got pretty extensive documentation. We really pride ourselves on the quality of this documentation. We think it's pretty cool. It's all authored in Markdown, so you're welcome to create your own, to contribute to it if you see something that's missing. I'm not going to go through it because we don't have time, but I do want to point out a couple of interesting links. These little lightning bolts, if you want to get started using a client, if you want to get started using a plain server, if you want to get started using the JPA server, click on any of those links, and those will take you to starter projects that have working code that will help orient you to this. I'm a developer myself. I get it. Documentation is fun, but nobody wants to read documentation before just trying to code out in the first place. So, try the get started links. If you're a developer like I am that just wants to do that, then that's probably what you want to do. The final thing I'm going to show you is our public test server. We keep this thing up 24/7. It does, I have to admit, it crashes more often than I'd like. People use this thing very heavily. It sits out there, it's unsecured, so anyone can upload their FHIR resources to it. Anyone can do any kind of search they want. It supports bulk export, it supports bulk import, it supports terminology services, it supports subscriptions. And so because it supports all these things and it allows anyone to play with it, people do manage to knock it over occasionally by, hammering it with just giant requests. And we have spent lots of time over the years hardening it, but we've still never gotten it to the point where it doesn't absolutely ever crash. If it's ever down, we're happy to hear about that. And we try and bring it back up as quickly as possible. Point being, this is a nice little test UI. This is the same test page UI I was talking about before. It's got all kinds of features, but I'm going to just quickly show you how to create a search on it. I'm going to go and do a search for patients with a name. There we go, with a name, and I'm going to type my own name into here, and I'm going to do a search. So that's search by name Agnew. It does a search, it comes back, and hilariously, it has found no Agnews on this server. So there were some the last time I tested. I suspect somebody has deleted them. Oddly enough, that wasn't me, so I don't know who has gone into our public test server and deleted all the Agnew patients, but that's it. It's a public server. You can do all kinds of crazy things with it if you want. So, I mean, that's always a pitfall of doing demos with a server is you never know what people have added to it. I will say, as a little funny aside, a few times in my life I've gone to demo it and people put all kinds of crazy things on this server. So that is a thing that happens. What can you do? This brings me to the end, I think, just about. Let me go back to my slideshow view. I will say we do provide commercial support if you're interested. I mean, the aim today, of course, is not to talk about commercial projects, but if you're interested in commercial support for HAPI, we do provide it. We've got a product called Smiled CDR, which is built on top of HAPI. So we're happy to talk to you about that. I've got these two templates talking about HL7 v2 and HAPI FHIR. I've already discussed everything that's here, so I'm not going to go through them, but they are there. And there we go. That's the end. All I can say now, this is our Google group. We would love to, if you want to join our community, this is the best place to start. And I've got a little detail on why we have a raccoon as our mascot here. Thank you to everyone who's joined us today. This has been a fun webinar. As I said, we will make the slides and the recording available and would love to hear from you in the future.
Thanks for watching. If you found this helpful, give us a like, subscribe, and hit the bell so you won't miss the next one.